So one last problem on conjugates. The question here is prove that 2 plus I root 3 power 10 minus 2 minus I root 3 power 10 is purely imaginary, and 19 minus 7i by 9 plus I power 12 plus 20 minus 5i by 7 minus 6i power 12 is real. Real means purely real, only real part is there, no imaginary part. So what exactly are we going to prove? So there is a property saying if z is equal to z bar, the number will be purely real, and if z is equal to minus z bar, the number will be purely imaginary. So on these lines only we are going to do the proof. First part, actually it's very clear, the question here you have a complex number and here you have its conjugate. So you take this as such, you take it as z and find z bar. Z bar means 2 plus I root 3 power 10 minus 2 minus I root 3 power 10, the whole conjugate, whole bar. Whole bar z1 minus z2 bar is z1 bar minus z2 bar. Using that property we can write this is equal to 2 plus I root 3 power 10 whole bar minus 2 minus I root 3 power 10 whole bar. But since z power n whole bar is also equal to z bar power n, I change this as conjugate of this power 10 minus conjugate of this power 10, which means you see what you are getting now, you are getting the reverse of this. That means this answer what you get as z bar is negative of z. So z is negative of z bar or z bar is negative of z implies the given z is a purely imaginary number. And in the second question, you can see both the complex numbers look entirely different. So we need to simplify both these quotients in order to find whether they are anyway connected. So that's what I'm doing, multiplying and dividing by the conjugate of 9 plus I and simplifying, as I have already told you, term-wise multiplication I'm doing, and denominator alone we can directly simplify as a plus b into a minus b. You can get the complex number, or rather reduce it as 2 minus I, as you can see here. And the next complex number 20 minus 5i by 7 minus 6i. Here also we are using the conjugate to multiply and divide so that you can again reduce the complex number to the minimum. So again I am multiplying term wise in order to get all this. This is quite familiar to you, so I am not going very deep into that. And so here you can rather simplify by cancellations, get it as 2 plus I. Now the given z is very clear, it is 2 minus I power 12 plus 2 plus I power 12. So z bar is the conjugate of the whole thing, and we can split z1 plus z2 whole bar can be split as z1 bar plus z2 bar. And moreover here you have z power n bar, which can be written as z bar power n, as I told you in the previous case. So this becomes 2 plus I power 12, this becomes 2 minus I power 12. And this is the same as z. Since it is plus here, both the numbers are same, which means z bar and z are equal, which implies z is a purely real number.